Hello everyone, welcome to our engineering graphics lecture series. I am Swapnil sir, and in today's video we will solve problem based on projection of straight line. So projection of line is very important topic in engineering graphics. This concept is the foundation for projection of planes and solids. So please watch this video till end and practice along with me. So the problem statement is in front of you. A line AB or a 90 mm long line AB is inclined to HP at 30 degree and 45 degree to VP. Draw its projections if point A is 10 mm above HP and 20 mm in front of VP. So the given data for this problem is, first write a given data. So true length of this line is given, a 90 mm long line AB. So true length is 90 mm. This true length of the line is inclined to HP at 30 degree. So theta angle is given in this problem. Theta is 30 degree. And this line is inclined to VP at 45 degree. So this phi angle is given 45 degree. Draw its projection if point A position is given. Point A is 10 mm above HP. Above means what? We can locate this point above XY line, and 20 mm in front of VP. In front, its meaning is we can locate this point below the XY line. So we can solve this problem very easily. This is basic level problem, and uh, in this problem, true length, theta, phi, and point A location is given. So for this problem, we required a reference diagram. So draw this reference diagram. This is the XY reference line. So freehand you can draw this diagram. So this is locus of A dash, this locus of A. Mark a theta angle. This is point A, this is A. Mark a phi dash angle. This is a point B1 dash. B2, this is a true length. Project and then rotate. So this is a true length. So if you project this true length up to locus of A, I'll get a B1 point, and if you rotate this point, I'll get a B point. This length is called as a plan length, and if you join AB, I'll get a plan length distance. From B, we can draw the vertical line directly. I'll get a point B dash. If you join A dash B dash, I'll get the elevation line. It is also called as the front view. This line is called as top view. So plan length makes beta angle with a reference line, and elevation length makes alpha angle. So here also we have the true length of this line. If you project this true length up to locus of A dash, this point naming is B2 dash. This distance is called as the elevation length. And if you take this elevation length distance in your compass, and from A dash, if you mark a arc, I'll get the same B dash point. So for this problem, for any line problem, we must know this reference diagram. So from this, we can solve this problem. So the step number first is draw a XY line or reference line. Draw a XY line. This is X, this is Y. Locate point A. So point A is 10 mm above HP and 20 mm in front of HP. So draw the locus line which is passing through this point. On this line, we can mark point A dash and A. So this line is called as a locus of A dash. This is a locus of A. On this point, we can mark A dash and A. So this is A dash point, this is A point. Now in this problem, theta and phi angle is given. So we can mark theta and phi. Theta is 30 degree, this is 30 degree, and phi is 45 degree. So this is 45 degree. So by using thin line, draw this theta angle line and phi angle line. Now true length is given. True length is 90 mm. So with the help of rounder, measure 90 mm distance in compass, and from A dash, mark a arc on this theta and phi degree line. So this point we get, this point naming is B1 dash. This you can see the true length point is B2. Now, now from this xy reference line, adjust a ruler and draw a locus line of b dash and draw a locus of b. So this point is called as a locus of b dash. This line is called as the locus of b. Now dark a dash b1 dash line and a b2 line. Now this line is inclined with HP plane at theta angle and phi angle. This is true length. This is also true length. Now we have the true length line. So project true length b1 dash up to locus of A and then rotate it. So we have true length. So project this b1 dash up to locus of A. I will get a b1 point. Then this distance is called as a plan length distance. So take A as the center, plan length distance in your compass and mark a arc up to locus of B. I will get a B point. Join AB. I will get the top view. This is also called as a plan length. This plan length makes beta angle with a xy or with a vertical plane. Now similarly we have B2 point. So if you project B2 up to locus of A dash and then if you mark a arc, I'll get a B dash point. So draw the vertical line, draw the projection line up to locus of A dash. This point name is B2 dash. This distance is called as a elevation lane. A dash to B2 dash distance is called as elevation lane. Now take A dash as a center and elevation lane distance in your compass and mark a arc. This point is called as a B dash point. Join A dash and B dash. So this is called as a front view. It is also called as a elevation length. And this elevation length makes alpha angle with reference line. Now you can see here, you can check our solution. If this B and B dash point is on a same vertical line, then our problem is correct. So we can measure alpha and beta angle. So answer, so we can measure elevation lane distance, plan lane distance for this problem. So elevation lane distance for this problem is, it is 65, elevation length is 65 mm, plan length is 77 mm. Then alpha angle is 43 degree and beta angle is 53 degree. So you can see the solution of this problem. Okay, so by doing these simple steps we can solve this problem. So that's the solution, complete solution for this problem. So in the next lecture we will solve another problem based on projection of straight line. So if this video helped you to understand the concept of projection of line, like and share this video with your classmates or friends. See you in the next lecture. Don't forget to subscribe for the next lecture. Thank you.